with that, we can move on to another image captioning methodology. And at the same time, we are going to introduce a new task, visual question answering. The video is online, so I'm not going to spend too much time on it. But what are we doing? Why do you say it is bottom up and top down? It's a bottom up and top down approach because from bottom up, you have an image and you're going to call your favorite object detection system. And we covered that in part 1 of the course. We go into a lot of details about object detection. You call your object detection system, it's going to detect a couple of faces, a couple of bodies, it's going to detect a food here. Now this is bottom up. Out of a single image, you're going to end up with a bunch of image patches within each one of these bounding boxes. And then each one of them you can vectorize. So each one of these boxes you can vectorize independently. And depending on the image, you might end up with a few objects or more objects. And this K here that you see, the size of this set of features out of a single image could actually end up being different or be image dependent. They're going to be different from one image to the next one. And this is bottom up. You found some regions of your image to pay attention to. Then you go ahead and you look at your sentences. You encode your sentences, and those sentences, each word in your sentence is going to pay attention to different regions in your image. And that one we know how to do. These are the vectors giving us the members of that image, and then you are paying attention to those vectors while predicting word T, while predicting subword T. And it's the same attention mechanism that we kept seeing in language. We are going to see it here. It's slightly different, but we also saw this formulation before. And the rest of it is writing down your objective function, which is going to come out of your likelihoods using the chain rule for probabilities, and then you're going to maximize the likelihood, or equivalently minimize the negative of the log of your likelihood, which is going to give you your cross-entropy loss. And in terms of the problem that you're solving, it is still image caption. There's an image, you want to output the corresponding text. You want to translate an image into a text. And then you can actually see what the model is thinking. When you output the sentence, 2 men playing frisbee in a dark field, if you focus on frisbee, you look at the corresponding alphas, you are going to see that the alpha with the highest value is going to correspond to one of these bounding boxes. And then you can highlight that. So this is the box that the model is paying attention to the most. Or when it comes to question answering, and if your answer is kitchen, you can see that the model is paying attention to this part of the image the most. And what is the task of visual question answering? You have a question, natural language, you have an image, and then you are asking a question from that image. For instance, what room are they in? And then there is going to be an answer. It's a multiple choice answer. So a pair of a question and an image should go in, and the corresponding probabilities over the list of answers should come out. And then the way that you're going to process this, the text, you're going to process it using your word embeddings. This could be your GRU, LSTM, RNN, transformer, or even CNNs. We have spent a lot of time on that. And then each word is going to pay attention to a region of the image. This is going to give you the top-down attention. Then you're going to combine the two, push them through fully connected layers, and then output n numbers. Any questions about visual question answering or bottom-up and top-down attention? Okay, was everything clear? Okay, awesome.